What a lovely day!
Welcome to Flat Earth Debate Uncut and After Show. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they premiere. There's also a PayPal, Patreon and crypto link in the info box below the video. Speaking of Patreon, I'm going to do a quick shout out to all of you who do support me on Patreon. So a massive shout out of appreciation to Abraham Mohammed, Adam, Adrian Quintana, Alistair Main, Billy, Blue Ridge Ranger, Burn Fat Till My Stomach Is As Flat As The Earth, Chow Yun Cat, Dank, Dave Rakia Gafford, David Robinson, David Wayne Foster, Daz Studio 68, Edwin Johnson, Erwin Jennisons, Felix Hung, Fireball X, God Rockin, Henrik 86, Joshua Balsimo, Kirsten Smith, Liam Nedrick, Life is Short, Maria Neelands, Matt, Missouri Bear, Nagara, Nathan Thompson, Naibai, Qatar Craig, Renee, Rob H, Sally Ballis, Silver Umbrella, Skeptic 936, Texas Mike, The Real Gabster, Tina Baker, Tom Herkins, Unbelievable Productions, and Windrider. So a massive thanks to all of you who have supported me on Patreon. You can probably see on screen now, I've also got a new member on Nathan Oakley 1980. So a massive shout out of appreciation to Light Energy. I'll also shout her out when we start the live show. In the meantime, I do believe we have a few people in Discord and G Plus server, so I'll raise the mics on them and you can enjoy their dulcet tones while I set up for the first live show.
Geodesics and so forth.
Honestly, hang out on Emma's channel. I'm sub to it, but I've never really been in there.
Yeah, I only do this QEs and Emma's channel. I don't do much more than that. Some of the guys here go there anyway, so.
Yeah. Goldbusters did like a video. It was like on the Matrix. I thought it would be something totally different, but like, I don't know. That topic didn't interest me. Maybe the rest of the video, if I skim through it, there's some good stuff in there, but.
Was it like a review of the movie or what?
I'm not sure. It seemed like it was started going into like Mandela effect and then like simulation theory, and I'm like, that's when an offer came to go for a hike, and I'm like, yeah, this is. I think I'll go for a hike.
I'd rather go for a hike. I don't blame you, man.
I normally enjoy some of the stuff Glowbusters does. And yeah, I'm not. Maybe I shouldn't have said that because it sounded critical, but it's just different strokes for different folks or something like that, right?
Well, I think Nathan was trying to get all of us to watch the first Matrix and come back and give our viewpoints on it, but that never happened.
Yeah. I can't actually.
Well,
I think it's on Netflix. Come on.
Simulation theory can be debunked
by the what you cut out.
Simulation theory is debunked by the definition of simulation.
Really? Let me look that up. Simulation definition.
What is the simulation theory, or is it a variety of interpretations?
Oh, wow. The basic idea is that we are existing in a simulation.
Like an illusion? Or?
Like the Matrix.
Right, so it's all an illusion.
So how does the which definition are you looking for?
Would that be correct?
Well, a simulation is it's a copy of reality, like a model. It's just a
right, but to have a simulation, I have to have. I'm having it, so obviously I exist. I can't have it unless I exist.
Right. A simulation is when you're copying something. It's like it's.
No, I get it. But they're not saying you don't exist, are they?
It's just an epistemological cluster screw whenever you get into.
That's a good point the 10th man made. We obviously exist, so.
Yeah, that's why I'm trying to see if they're synonymous, because the whole concept of everything's an illusion falls apart, because if I'm having an illusion, I must exist to have it. So it's over right there.
Well, the idea that you're not in base reality, there's no way. I mean, it's a claim that you can't verify,
No, of course not. But the point, if you're having it, then whatever you're having is your reality.
Right, like I said, it's just an epistemological cluster screw. That's what they just, talk in circles.
No, I agree. There's nothing that they can do to prove it, or it just heals itself.
It's the idea that if you embrace absurdity, you can explain anything.
Now, that's a good way of putting it.
But just because you can't prove it doesn't mean that it doesn't exist, though, correct?
Well, the idea that we're living in a copy of reality is debunked by the fact that we are in reality.
Agreed.
It's like when Socrates or Plato said, the only thing I know is I don't know anything. He debunks himself in that statement,
Yeah, because he's got to exist to not to know the very question he's asking.
Right. He has to know that he don't know nothing. So that means, he's in contradiction in the sentence, and it's,
Yeah,
epistemological cluster screw.
He knows that he knows nothing, so he knows.
Right. You know what I mean? It's just, it's absurdity is all it is. I think, can somebody tell me if they've ever heard of this fallacy? I can only describe it. I've been looking for it, but I can't find it. It's like when you say a brain is like a computer.
False equivalence?
Well, no, a computer is like a brain, but the brain came first. So that's like it's like a generational fallacy or something like that. It's like saying you're like your kid.
Yeah, but you came first, so your kid's more like you, is what you're saying.
Yeah, exactly. When they say the heart is a pump, the brain is a computer, it's a fallacy because, one preceded the other.
Well, I did hear a while back ago, many, many years ago, that they studied the human body and the organs and what they do, and they designed mechanical structures or mechanical objects to do the same thing, like a pump. They got that from the heart pumping. So it's an interesting concept, but I do agree that many of what God has already put in us,
JD, come on.
People, engineers and whoever has studied it and made a mechanical replica, like an engine, like cooling device, like a radiator, all that stuff.
Right, but they'll take the fact that they can make these parts and then say that, look, it can this somehow proves evolution. Just like it's shocking.
Nice try. What is evolution? We still don't have a definition.
It's a second law of thermodynamics belief.
Mm-hmm.
Or it's a contradiction to that.
Violation, yes.
First law, not second law.
But does anybody know what that fallacy is called, where you say the brain is a computer?
Can you say what? The brain is a what?
Well, have you ever heard someone say the brain is like?
So the brain is like a computer.
Saying the brain is like a computer? False equivalence, okay. False equivalence?
That's what I was saying.
Well, I mean, it kind of is, but it's like a computer is like a brain because the brain came.
He keeps cutting out.
You keep cutting out near the end of your sentences.
I'm using push to talk. I think I'm letting go too soon. But I'm saying is a computer is like a brain, but it's not in reverse.
Right, because the guy with the brain had to make the computer.
I'm improperly calling it a generational fallacy because I don't know what else to call it.
False equivalence.
Well,
I think he's
they
trying to
base entire belief systems like.
I think he's trying to tie in which came first. So obviously the brain. So he's having a problem with false equivalence with that one thought.
Right, because it's not a false equivalence to say that a computer is like a brain.
Depends how technical you are. The computer I'm using is processing everything one at a time. Well, depending on the type of processor, but in a simplistic way, it's having to process each individual binary process one at a time. So, for that reason, let's try and give you an analogy. If you're trying to emulate an old game console, a lot of the functionality of an old game console, like an old Nintendo, is done with switches in real time. So you press a button, something actually happens, a gate opens or whatever. And you can have multiple gates open at the same time. Now, you can't actually directly process that in a normal home computer in the same way. You'd have a certain degree of latency because it has to process it one, then the next, one after the other. So it's not. The thing is, it's so fast. Processors are so fast that you couldn't tell, but that is literally how it's functioning. So, in comparison to a brain, you can do multiple, literally tens of thousands of different functions all at once in a brain, but you can't in a computer. It can seem that way because it could process them very, very, very quickly, all one at a time, but it's operating on a completely different standard. So, in some ways, in a simplistic way, you could say, well, a brain's very much like a computer. But then somebody comes along and goes, well, no, garbage in, garbage out. Your brain isn't like that.
Yeah, I was just pointing to the belief systems that are out there right now that kind of build on the whole idea of that fallacious start.
Sure.
For example, transhumanism.
Yeah, it's pushed on the public though, isn't it? With all the transhumanist movies. There's loads of them. And, giving you this concept that might happen in your future. It's part of the brainwashing as far as I can tell.
I agree.
I didn't catch the beginning of this conversation. How did this all begin?
We were talking about simulation theory and how it's debunked by the definition of simulation.
Okay. Definition of simulation, then.
I think the fallacy you're looking for is metaphorical fallacy. I might be wrong.
The metaphysical fallacy. That's a new one on me.
Metaphorical.
Oh, metaphorical fallacy. Oh, okay.
Someone just read the definition of simulation. Read it again.
Okay.
I'm glad you volunteered.
Well, there's a couple. What do you guys want? Merriam-Webster, Cambridge?
Yeah, Webster's fine.
Webster and either Cambridge, Webster, doesn't matter.
Okay, we'll start with Webster. Simulation is the act or process of simulating. How to use simulation and sentence. Okay, let's go to Cambridge. A situation or event that seems real but is not. Used especially in order to help people deal with situation or events. And then there's the one that Google suggests at the top. I forget where that one comes from. Oxford or I don't know where. It says something interesting in the Google one. It says the action of pretending. Deception. That one was interesting.
Okay.
The production of a computer model or something, especially for the purpose of study. Imitation of a situation or process.
Well, I think it's context-based. So if you're in a flight simulator as a pilot practicing before you do the real flying versus the way the metaphysical world wants us to think that we're living in a simulation. Am I right about that?
Yeah, it's trying to imply falsehood. So while you can describe certain aspects of quantum mechanics with a rendered reality, it doesn't imply a simulated reality. So I see what you mean. It's debunking itself by the virtue that it's saying it's false. Well, by our own existence, we can, I think therefore I am, we know we're real. But that is a philosophical argument. Nevertheless, some of the scientifically valid arguments in quantum mechanics lead you to the understanding that information doesn't exist without a knower. Therefore, there's certain aspects of physicality that wouldn't exist without information and knowledge, and therefore a knower also. Therefore, you can infer certain aspects of rendered reality from that. But that, again, doesn't imply simulation. Simulation being a falsehood, a replication of something else.
Right. You can't say that reality is a replication of another reality unless you've experienced reality.
Precisely. We can't step outside of, if it were to be argued as a false reality, to step outside of that false reality is no more likely than Mario stepping out of Mario World.
Or seeing two horizons.
Or having two horizons.
Taken an analogy
that's just
and built a worldview around it.
That's just a breach of the definition of horizon there, 10th man.
Well, they have several now, so they're seeing more than one.
Let's just nip that in the bud. There's only one position where the sky meets the ground. It's apparent because the sky doesn't actually meet the ground.
Agreed. Oh, I had to get it back on track.
But your height matters, doesn't it?
Yeah, a geometric horizon is apparent based on height, correct.
But that's just not the horizon we experience.
The horizon we experience is not physical and geometric, by any stretch, no. It needs to be if you've got a globe religion and the globe religion is based on physical evidence claimed to be in the form of geometry, requiring you to have a geometric horizon to do the geometry with.
But they say that it's only could be seen if there was no atmosphere.
Then they
so
can't
they
ever
blame it all on refraction.
Well, then they can't ever draw a straight line to anything. If you can't see
So
the
they can't do
geometric horizon,
geometry.
if you can't see a geometric horizon, you can't do geometry. If you can't draw a straight line to the geometric horizon, you can't do geometry. So they can't do geometry anymore. We've killed the R value. The R value gave them a physical geometric horizon. And in their side-on models that don't represent reality in any way, shape or form, they will draw a straight line to a physical geometric horizon we don't experience, while simultaneously telling you just how bent the light is. So they got bent light, but they'll draw a straight line to something you don't see. It's complete nonsense.
Where did they get their calculations for bent light?
Calculations for what, sorry?
They're bending light.
Oh, they got that from an extrapolation and assumption that they can draw a straight line to a geometric horizon based on an R value.
Which they can't see.
Which they can't see or draw a straight line to because they're all bent according to them. It's completely game over.
It's such a cluster screw, right?
Yeah, it's a complete cluster screw. Every single turn after the Black Swan is a flamethrower for anybody arguing for the side of the globe. The model is totally untenable at this point, and arguing for it only leaves you digging a deeper and deeper grave.
Even when they say the
Getting out again.
even when they, what is the telescope that tracks the sun?
I don't know what you mean. Do you mean an equatorial mount? Is that what you're talking about?
Possibly, but even that one falls apart if the horizon isn't geometric.
Yeah, a lot of their rhetoric is based on the R value, giving them a physical geometric sphere edge for a horizon. That's correct. Most, if not all, of the model completely implodes upon itself after the Black Swan argument. In fact, it's wonderful.
But they'll say that the R value is an approximation because the Earth isn't a pure sphere. It's more of an ellipsoid.
Doesn't matter. It's so beyond the tolerances of a physical geometry that they could assert, you know, the error that you would get from the slightly varied radius they claim is within margin of error when you're looking at the images and comparing them the way they want us to compare them with their side-on geometry, Muppet vision, perspective exclusive mathematics. We'll get my tongue around it.
Right. So when they say that, then we say, well, how'd you get your factors for 7 over 6R then?
They don't. They don't have an R value to extract out anymore if you can't see a geometric horizon or draw a straight line to anything. So utilising the geometry is null and void from that point on. As soon as they relinquished the physicality of the horizon, that's game over. That's the end of their model and argument. They don't know it yet, which is great. I don't mind dragging this out indefinitely. Great. Because you're never going to win an argument.
I'm referencing Mr. Sensible here, where he says the best you've done is disprove our radius. So, all right. So we disprove your radius, but didn't you get your 7 over 6R for refraction from this disproven radius? So then that's all wrong.
Yeah. Wouldn't you need to draw a straight line to the horizon in order to perform geometry? And your whole argument for why the horizon's not where it's supposed to be geometrically is that we've got bent lines, eradicating any chance of doing any geometry from that moment on. No geometric horizon, no straight lines. All right, not going to be doing geometry then.
It's the greatest R whoosh moment in history.
R whoosh? What the hell's that?
That's the sound of something going over somebody's head after they say it.
Yeah, like when they tell you, well, obviously, the horizon that I argue for and have a religious belief in because it tells me I've got a sphere beneath my feet, that R value giving you a geometric horizon that's physical, that's not physical, it's refracted. Now, they don't phrase it like that. But if they did, they still would have the R whoosh moment and it'd still go over their head, even if they literally said, look, I argue for physicality. I argue for standing on a physical sphere with physical sphere geometry and a physical sphere horizon for boats to go over. What's that? Black Swan? The horizon's not physical, it's refracted. It's just like, are you this stupid? Sometimes in the same breath, which is the best ones. Those are the greatest, when they literally say it in the same breath.
Or you can pull a rumpus and say, okay, well, then I live in the Matrix.
Yeah, you could go to Brain in a Jar. That was his first port of call. He hasn't really revisited that since, I notice.
No, but
The
they'll say
smarter ones
anything
like
other than,
Rumpus.
you got a point. The Earth might be obviously and observably flat and motionless. They won't go there, though.
No, they'd sooner have you believe you were a brain in the jar than declare that it's flat. It's so far removed from their religious belief that they just could not ever say it. So yeah, you're much more likely to be a brain in a jar than accept the obvious and observable nature of a flat reality when they're telling you they don't have geometry anymore. But no, it couldn't possibly be flat. We're definitely in the Matrix.
A brain in the jar. Abby normal?
Yeah, it's
You remember
essentially
that?
a Matrix argument. We're all in the Matrix. You wouldn't know if you weren't a brain in a jar. How would you know the difference?
Yeah, it was a joke from the old Frankenstein movie.
Oh, I missed it.
The
Sorry.
brain was Abby normal. Abnormal brain.
Abby normal.
It was Abby normal.
That was Gene Wilder, right?
Yeah.
I just seen that movie last night. That's odd. That's odd.
What's the movie? The Man with Two Brains?
Well, I'm sorry, say again?
What's the movie you're talking about?
The Gene Wilder Frankenstein movie.
Oh, okay.
He sent Igor to the lab to get a brain, and he's found a brain and thought it was Abby normal.
Mel Brooks' Young Frankenstein is what it's called.
Yeah.
Ah, okay. It sounds like a Mel Brooks movie.
It was
He grabbed an abnormal brain.
Mel Brooks is a genius.
She's gone from suck to blow.
I remember asking about that movie Spaceballs when I was a kid. Like, how? Why does what? Yeah.
Was that the exact phraseology?
Yeah, like it wasn't clicking in my mind. Like, if space is a vacuum, why are they using a vacuum cleaner?
I'd love to get inside someone like Mel Brooks's head and ask, or see the
Well,
processing.
it's almost in that movie. It's almost as if Mel Brooks knew.
Almost.
What the epi argument is. If you pay attention to the movie, I've got 3 short videos on my channel that describes, what I'm talking about.
Your channel's Matthias, the Walking Wounded.
Same as my name, Matthias, the Walking Witness.
Matthias, the Walking Witness.
It's even the part 3's even got some of your stuff on it, with the you and Giggles vacuum without a container, and it's got.
Oh, I do vaguely remember seeing that. Yeah, when this goes out in the pre-show, I'll dig out one of your videos and I'll spam it to the pre-show audience.
No, well, I made 3 different videos. They're all short.
Yeah, like I say,
Hey,
I'll pick a random one and spam it.
Hey, if Rumpus comes on again, I'd like to ask you questions. Can I read them to you?
Yeah, good.
All right. 1. Is it an actual location, meaning geometric horizon, question mark, 1.23 miles at a 1-foot observer height? Question 2. Is it arbitrary, one to which any value can be assigned, question mark, or is it geometric? Is it based on personal preference, question mark? 3rd question, Rumpus. Radius of Earth. Some give it 3959. I believe Andrew Thomas Young cites 3963. 1-foot observer height is 1.23. 7 over 6 R is 1.32. Are these real measurements? Are these assumptions or real? Question. Fourth question. Rumpus, are there any fixed values that apply to the real world? Question mark. Fifth and last question. Rumpus, are real accurate observations possible at sea with a sextant? That's 5 to start with.
Good stuff.
What do you point the sextant at when you're measuring the sun?
Well, you point the bottom part to the horizon, which is at 0. And then whatever luminary, could be the sun, the moon, or some of the stars, excuse me, used for navigation, or 4 of the wandering so-called planets. And that's your zenith would be 90 degrees. So at noontime, if the sun or whatever luminary is directly above you, that would be your zenith. And the horizon would be at a right angle at 0. So normally, if you're
The
doing it, it's going
horizon
to
you
show.
see, or the geometric horizon, or the refraction? Which horizon is
We
it?
only have one horizon.
There's only one horizon for any navigator, and that's the one you see with your eyes.
Yeah, we only have one horizon. It's just not geometric.
I sent a picture of a Fata Morgana, the one that QE shows with the boat hovering in the sky, or appears to look like it's hovering in the sky. You know that one?
Mm-hmm.
I sent that to a celestial navigator and asked him where he would point his sextant to. And he said, he did the LOL, laughing out loud. I've never had this one ever presented to me. But he said, just where the water is, that's good enough.
Yeah, in other words, I'm not going to be pointing it at the false horizon.
Right.
I'm just going to point it at the horizon, which with off-center vision you could see in that picture, or if you adjust the
Right.
contrast settings.
Then I was reading the accuracy of a sextant, and naval instructed navigators who do it on a daily basis, even though there's GPS, ground positioning, right? They can get up to the accuracy of 1 nautical mile, which is pretty good. The plastic sextants aren't as precise as the metal ones, though. I'm actually looking to buy one. Saw one on the eBay, normally like a close to $1,000 sextant, but I'm waiting for the price to go down.
I get you a real good price on one if you buy 2 horizons from me. Got your back.
Ooh, with chocolate on top?
You already know.
Thank you. Hey, good morning.
Good morning, guys.
Hey, Chocolate.
Good morning, Chocolate. What's up, man?
The only reason I said that is that if the horizon is how they say it is, then their sextant would be useless.
Precisely. The sextant proves we live on a flat plane.
Hey, Light Energy. On mute. No. So you joined as a member. Thank you very much. Not being on the mic.
Everybody had a good weekend?
Yeah, it was very nice. Thank you very much.
Good to hear. Good to hear.
And you, Chocolate?
Yeah, it was cool. I mean, it was only yesterday because I worked on Saturday. Yeah, it was cool. Back at work. Everybody's scared of Corona. Ridiculous.
They're pushing that thing like crazy. I posted a video on my cooking channel, Nathan and Chocolate, and it was Grandma's chicken soup recipe. And Dank, you know Dank, who comes on the show a lot in chat.
Yeah.
He goes, Grandma's soup. She cooked it so thick that the kitchen would go around when she stirred it. And then he followed it by saying, she called it chicken Coriolis. And then,
Wow.
and then I responded, Dank, I think you're thinking of stir-fried chicken. Clockwise stirring method and counterclockwise. Self-imposed unless you're on the rotisserie spinning wheel. Then it's an apparent stir.
Oh my God.
I got
an extended pun.
It's going into chat now.
Sorry about that, Nathan. I was in a place I couldn't talk. Yeah, I redid my membership because I had to change my credit, debit card stuff that happened that shouldn't have.
It shows you being a member.
Huh?
It shows you being a member.
Yeah, because it was connected to my old debit card number.
Okay.
So it lapsed for a second.
My camera died. Too late to worry about it now.
I can go into YouTube if you need the slot open for a Glober.
No, we're all good. Don't worry about it.
Okay.
Nathan, you want me to send the link to Bev to join us?
Yeah, I need to add him to Skype.
Yeah, what do I do? Just copy it and send it to him? Is that all I need to do?
For the Hangout, yeah. Right, I'm going to start the live show. See if my camera works. Probably not.
Oh, what a day! What a lovely day!
Welcome to... Oh, my camera's definitely frozen. To Flat Earth Debate Live. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon, and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below, I can't see me, this video, to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show on Facebook and Twitter. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. See if I can actually get the other camera working before Use the panel. Does that work? That's the backup camera. Hey ho, technical issues. We are joined by Righteous Force. I don't know who's got the. Is that Bev? And Chocolate Sane and 10th Man in G+, together with a whole bunch of people in Discord. So, welcome one and all.
Good morning.
Hello, hello.
Terrible intro.
Good morning, Vietnam.
Worst start to the show ever. Cameras froze, and I'm like, oh god, where's the backup camera? I can't find it because it's been months since I've used it. But hey ho, let's do a bit of housekeeping. Who is it? Is it Bev? Was I right? Yes, it is.
Yes.
Hey Bev.
Yeah. Hey.
Are you on Master B now? Has somebody added you?
No, not as far as I'm aware. No.
Oh,
No, I just sent him the link.
Can you add him to Master B? Do you know how to do that? Should be doing
No,
this
I
in the
don't.
pre-show, really. But hey ho, let's do housekeeping before we get into endless admin. Any evidence of a physical Earth curve?
No.
Only in the globe reification model.
No? No signs of Earth curve at all?
No.
A hill.
Absolutely zero here.
Any evidence of axial rotation of the Earth-based variety?
No, I don't think so. Just in the books, pictures.
Any scientific evidence of gravity?
What is it?
Only in the reified globe reification model.
Get some repetitive answers, it seems, today. Any evidence of the distance to the sun?
It's over there.
Oh, it's not here. It's late. Any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
That's a good one.
That doesn't sound
no.
possible.
That's a negative, Ghost Rider.
Any evidence of the R value, Earth radius?
R
That's
value.
been smashed.
No. Because at best, what has happened is the R value has been debunked. At best, of course.
Any single viable hypothesis from any of the fields of astronomy, cosmology, or astrophysics?
I don't think they qualify for scientific evidence in those fields.
I'd agree. I think that's it. That concludes the housekeeping.
No, curvature.
Gas
Forgot
pressure.
Curvature. Gas pressure, curvature.
Oh, gas pressure. No, I did curvature, both of them first. So, any evidence you can have gas pressure without the necessary antecedent of a container to press upon?
I have something on that.
Oh, good round out to the housekeeping. Go ahead.
I'm an instrument tech. I work with pressures all the time. And one of the things I've noticed in this debate is the Globers are quick to confuse differential pressure with vacuum. But there's actually three different kinds of pressure. There's absolute pressure, differential pressure, and atmospheric pressure. And if you don't pay attention, they'll do like a cup trick with it.
So go on then. You explain the bait and switch that they use.
Well, they'll say vacuum and then describe that as a differential pressure. But when we're talking about vacuum, we're talking about absolute. That's all the way to zero.
I see.
Yeah, I've heard that nonsense. Zanuck has said things like, a pressure differential would be a vacuum. So if the pressure is different at your feet than at the top of your head, that's a vacuum because you've got a pressure differential. It's ridiculous.
Yeah, he's doing a bait and switch with you. He is actually not addressing the point. He's talking about something else.
Oh, I know. It's the same thing like when he says with the wings. Oh, you got a pressure differential above the wing and below the wing. When our question is, how do we have the pressure at all? But he wants to say, oh, that's that. There you go. That's evidence of a vacuum without a container because you have differential pressure. It's just another way to try to sneak in their nonsense and hope that people aren't paying attention. So yeah, you're absolutely right, man.
Yeah, quantum race.
Hang on. Not only Zanuck, but Dr. Danny Faulkner said an airplane wing at 30,000 feet has less pressure above it than below it. So there's your vacuum. So it's not just
funny thing is, I heard Zanuck with that first before Danny. Danny tried that old banana in the tailpipe first, so Danny was late with that.
I concur. I concur. Zanuck was the first to say it for my ears to hear as well, but I don't know when Danny came up with it.
Well, the next time they try that shell
he
game
probably
with
got
you,
it
that's all
from
you have to
Zanuck,
say.
which wouldn't surprise me, because he did get his little vacuum without a container video from, who was it, Hillbilly? Mr. PhD over there. That's who you cite, Hillbilly Blue Balls, for your vacuum without a container.
Yeah, but
Meanwhile, you have two containers.
I thought he said you shouldn't go to YouTube videos for your sources.
That would mean if it's like one of those do as I say, not as I do.
Well, that's incomplete. So he didn't say, look, you shouldn't go to Google. He said you should go to him, so he can go to Google.
Yep. Right. What's up, Arwen?
So to summarise the argument, we ask how you can have gas pressure. That'd be X in this instance. X is gas pressure for this argument. How can you have X, that would be gas pressure, without something to press upon, a container? Gas pressure is, by definition, the force exerted on the walls of its container. That is gas pressure. How can you have gas pressure without the necessary antecedent of containment to press upon? They address this argument by saying, we can have delta X, that would be gas pressure gradients. And then they address how they have gas pressure gradients, a delta of gas pressure. So when they describe an airplane wing and the differential in pressure it creates with the Bernoulli effect, we would immediately say, how did you have the gas pressure in the first instance to push an airplane wing through to create a differential? How did you have gas pressure in the first place? If you're claiming we don't have a container and that the sky is in fact a vast void the gas we breathe could fill. Gas wants to fill the available volume it has to fill. That's what gas does by its nature. Fills the available volume. Go speak to MIT about entropy. That's what gas does. It's gas behaviour. So gas wants to expand at high speed in all directions, and it's claimed, if you're a heliocentric religion believer, then it's claimed the sky's a vacuum. Outer space is a sky vacuum. Well, the gas we're breathing would want to fill that space. It would want to expand in all directions to fill the available volume. Hence the question, if the sky is a vacuum, how can we have gas pressure without a container? The gas we're breathing would fill the space. Well, they don't address that question. They address how you have a differential in gas pressure, not addressing how we'd have gas pressure in the first instance. It's just a red herring.
Exactly, and they do that by the three different types of pressures used by...
You're cutting out again.
The way that they do it is engineering. We use three different types of pressure, and they substitute the one we're asking about, which is absolute pressure, for differential pressure.
Right. How can you have absolute pressure without a container? Well, once we've got pressure, absolute pressure, we can create a differential within that pressure, and we're going to talk all about that. That's what they do.
Yeah, absolute pressure goes to zero. Differential pressure only deals from atmospheric up.
I see. Atmospheric being atmo, air, and sphere, fundamentalist religious belief. I noticed.
Yeah, I just thought that was interesting how they did that little shell game.
Sure. Most of the arguments for a globe Earth are a shell game. Bait and switch. What's it called? Follow the lady.
You forget there's that other little sneaky one they try to do, which say gas pressure is different from atmospheric pressure.
Yeah.
Just funny, because what's the atmosphere made out of again?
Atmo.
What?
Part of
What's Atmo?
air.
Check, check,
That would be
check. Can
gas,
you hear
right?
me?
We hear you, Babs.
What up, Babs?
Yeah.
Can I get?
Morning,
Hey,
guys.
Owen. Hey.
Are we still doing housekeeping?
We're kind of doing it. We're on the last question. Hey, Owen.
Hey, can I have a little special type of ball or a bottle? To the.
Can you have a what? Sorry, I was
gas
coughing.
pressure?
Say again, Owen.
Can I have a special ball or a bottle?
A special ball or rebuttal. Yeah, do you want a little drum roll? Dun 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 dun. Go ahead, Owen.
Okay. At most, you've disproven gas pressure without a container. See it?
At most.
At most.
Oh, got it. That took me a while. Chocolate's on the ball, thank God.
I got it.
Any more, Owen? Because I think Babs has got something to say.
No, that was it.
Good joke, though. Very good.
Thank you.
Babs?
Yeah, I do have something that I want to say. And I wanted to present this to you guys last week, but I was kind of busy. And it was also pretty busy on the show. Like, the Discord was packed and didn't really get an opportunity to jump in and share with you guys this new findings. So I'm going to get Righteous Force to share some images on the screen.
All right, you're presented.
Okay, good.
Well,
I'm just looking at the YouTube page right now, so I might be a little bit delayed. Right, so Hillbilly Blue Balls, also known as Billy Blue Balls, made this video last week. And undoubtedly, this was a response to the discussion that you and I had about perspective and how it relates to Polaris and angular size change and how we can apply it to flat Earth and observations. So what Hilly Blue Balls chose to do in this video was to use these blocks. They look like Jenga blocks, and they're all arranged equally spaced away from each other, and they're all the same size. And basically, what he's trying to show us here is that perspective is a real thing, but as far as the globe Earth arguments are concerned, they don't use perspective to represent obstruction, because they prefer using orthographic view, because in orthographic view you're able to show everything pretty much from a side view. You're able to represent like all the objects that are being observed or all the objects that are in question. And in perspective view, you don't really get the opportunity to do that. So if you could go to the next image. Perfect. So the argument that he was making here is that the only time where we see perspective, which is things getting smaller the further away they are from us, in relationship to our observation or viewing point, the only time perspective is a factor is when the objects are different distances away from each other. But as you can see here in this example, we don't see perspective from a side-on view because these objects are equally distanced away from us. They're all at the same distance away from us. That's why we don't see that effect. And could you go to the next image, Righteous? Right, so further demonstrating that point here, that we only see perspective when we're observing objects that are moving further away from us. But if they're equally distanced away from us, we don't see this effect. Next image, please. Right, and we see this here with these fence posts. As the fence posts move away from us, their sizes change. And these measurements can either be angular size or apparent size, just depending on how you choose to measure these. But the fact still remains that objects that are moving away from us are changing in size. They're reducing in size. Okay, next image, please.
Reducing in apparent size.
Correct. They're not actually reducing in size, but their apparent size is reducing. Okay. So, as you can see here, with the two images juxtaposed alongside each other, the fence posts remain the same size as long as we view them from equal distances. It's only when we view them from different distances that we start to see this perspective effect. Next image, please. Okay, so this change in apparent size isn't necessarily constant. It changes based on your location and your elevation. So the higher up you go will affect the rate of size change. So what I was trying to do was trying to get like a fixed rate to sort of calibrate how these objects are changing in size the further away they move from us. But one thing I realized is that there's no fixed rate as far as perspective is concerned. All that we can say for sure is that things that are moving away from us are always going to be reducing in size. Next image.
One minor correction. When you're saying rate, you mean angle. The angle that you're taking these images from is what will determine that. So
exactly, the angle, yeah. The angle that you're viewing these images from is what's going to determine the rate. If that makes sense.
Yeah, you're using the word rate, you mean angle. Perfect. Next slide.
I mean angle, correct. Okay, next image.
This is the next image.
Next one, sorry. So as far as how we can apply these measurements to what we're looking at, as far as the images that we're viewing, there are different calibrations of measurement that we can use to measure these. Since we're looking at photographs, we can either measure pixels, inches, centimeters, millimeters, points, picas, or columns. But it doesn't really matter what scale you choose to measure these objects. The fact still remains that the further away objects move from us, they change in size. Doesn't matter what unit of measurement is being used, that fact still remains. Next image. Okay, so I've presented this before, and I feel like it's a good representation to help people understand how perspective is applied as far as flat Earth and observations pertaining to flat Earth are concerned. So in reality, we know that anything that's below our eye level can't obstruct things that are above our eye level. And I'm using this red line in this image to represent our eye level. And I'm going to demonstrate to you how obstruction can work as a result of apparent size change and perspective. Next image, please. Okay, so we can see that the ground appears to rise up and get closer to our eye level as a result of perspective. Now, in actuality, the ground is not rising up. This is just an effect that is the result of our eyesight. Our eyesight tends to make things converge to a point. The further away in the distance, whatever it is we're looking at is. So this is something that isn't taken into consideration in orthographic view. When we're looking at things in side view, we can't really represent this apparent rising of the ground and this apparent stooping of the ceiling. These two things can't be represented in orthographic view, and this is why this is important in terms of the observations that we're looking at. We need to represent what is actually taking place in reality. Next image, please. Okay, so on the sides here, we can see that there is this shrinking or this apparent angular size change that happens the further away we look in the distance. This is also something that isn't represented in orthographic view. And this is also something that can affect how much things are obstructed when we're observing objects in the distance. Next image, please. Okay, so here we have an object in the distance, and about 3/4 of this object is below our eye level, and 1/4 of it is above our eye level. Now, what I'm going to demonstrate to you is if we have an object that is the exact same size as what we're looking at in the distance, if it's closer to us, it's going to be larger in angular size than what is further away from us. And the result of this is that something that's shrunken or reduced in apparent or angular size as it moves further away from us can be obstructed by something that is closer to us and is larger, as long as it is all below our eye level. So next image, please. So you can see that this object here is being obstructed by another object that is the exact same size. The factors to keep in mind here are that the size, the difference in angular size is what is resulting in this obstruction. Next image, please. Okay, so here we have the typical images that are presented to us by the globe earthers. They show us an image in a side-on view and ask us, why is this being obstructed? We should be able to see it. And they neglect representing angular size change. They also neglect representing the effects that we discussed prior to this, which is the ground appears to rise up or get closer to your eye level the further away you're observing objects in the distance. Now, this is not represented at all in this image, and it gives the misguided idea that this is what you would expect to see on a flat Earth. But realistically, this is not how our eyes work. This is not what we see in reality. So telling people that this is how flat Earth should work, and this is, how things should be represented on our model is false and incorrect. Next image, please. Okay, so here we have a hydrostatic leveling rig, and this is a tool that you can use to measure the horizon in relationship to your eye level. And we can see that at sea level, the horizon is actually at our eye level. Now, why is this important? This is important because majority of these observations that we're doing are at sea level. So we're looking at things that are at our eye level. And what we should apply is that rule that anything that is below our eye level can't obstruct anything that is above our eye level. So we notice that in most of these observations, all of the obstruction is taking place below our eye level. Now, what we need to do is apply angular size and start looking at how what is obstructing these objects in the distance is actually doing. For example, if we have waves that are closer to us in the foreground if they're larger in angular size, is there a possibility that they could obstruct something that is further away, something that's reduced in size, just like those two objects that I showed you previously? One was smaller than the other, and that resulted in obstruction. Okay, next image, please. Okay, so as we increase our elevation, we notice the horizon drop. This is this is one of the ways that the Globers are able to reificate their model by saying that we observe horizon drop, therefore we're on a curved surface. And they completely ignore atmospheric effects. Not until recently, when they admitted that the horizon is apparent, it's always subject to refraction. So keep this in mind whenever they want to mention that the horizon is dropping as a result of curvature, when in actuality the horizon doesn't have a fixed location. It's either closer to us or further away from us based on atmospheric effects, not as a result of Earth's geometry. Next image, please. Okay, as you can see here, further up we go, the horizon gets lower from our eye level. Why this is happening? I believe it is a result of atmospheric refraction and not Earth curve. Next image, please. Now, how this relates to everything that we've been discussing thus far, as far as the black swan is concerned, is that we've heard the Globers state that looming is what causes us to see further than what we would normally see on a geometric globe model. But in reality, we never see looming. Looming isn't a real effect. As far as I know, what we're seeing is inferior mirages. We're seeing boats that are being inferior miraged, and people are asserting that that effect that we're viewing is actually looming, when in actuality it's not. It's inferior mirage.
Could you make a minor correction? So in the case of looming, what you would have is an inferior mirage of the sky below the boat. The boat's still in the same position it always would be, but the inferior mirage isn't the boat, it's the sky.
It's the sky, exactly. It is the sky that is being inferior miraged, creating the illusion that the boat is floating, when in actuality it isn't. It's just the sky that is being refracted. Next image, please. Okay, so this is how the looming effect works. We know that light tends to bend towards a denser medium, and cold air tends to be denser than warm air. So in order for this effect to work, what would be required would be a colder layer of air above the warm layer, which would result in the light bending downwards. Actually, sorry, I got that backwards. What would be required for the looming effect would be a colder layer of air below a warm layer of air. So therefore, the light would bend towards the denser medium, which is the cold air, and it would bend in a downwards direction, which would cause what we're looking at to be loomed upwards.
I'm just going to bring some clarity to that. I'm sorry, because that was just slightly convoluted. I'm really sorry to add to your presentation. So if you can't tell already, this is a Muppet Vision representation. Therefore, this will be the Globers' description of what looming would be in their representation, side on with you seeing your own head. Not that we see that in photographs. Nevertheless, what's just been described is how they describe the boat being raised up and the effect that would be needed for their argument for that to happen. So this is a devil's advocate from the globe side, what they say about looming and what would be necessitated for that to happen. Hope that's clear.
Exactly. Yeah, just to make it clear, this is all on the globe model. So if we could go to the next image, please. Right. So this is a demonstration of the inferior mirage effect. Here we see the boat appearing to hover or levitate above the water, but in actuality, that's not what's really happening. The sky is just being inferior miraged below the boat, creating this effect. And I think this is what the Globers think looming is, but it really isn't. Because do you really think this is a hologram of the actual boat being loomed up behind Earth curve? That seems.
Again, I'm really sorry. I'm really sorry. This is what they think their version of looming is. So, based on the explanation just given about the boat being raised up, they, the globe heads, would assert that this is the true horizon, the geometric Earth curve edge shown in their model, marked with an X and labelled horizon. That's what they would say this is. And on first inspection, that seemed fairly obvious, right? It's the hard line. Therefore, that is the horizon, right? Well, no. If you use off-center vision, you can see that the horizon is precisely where it would be on any other day. And so is the boat. In other words, if you came back when you didn't have an inferior mirage of the sky below the horizon, so that's where your mirage comes from. This is an actual description of what's actually occurring, as opposed to the demonstration that was on 2 slides ago, where you've got your eyeball looking up from the left. Well, as you can probably tell, we don't see the side of our own head in this picture. That's the first problem with their depiction, and the light bending the wrong way round based on how the actual heat of the temperature in the air and the water would be means that their explanation is nonsense. The point is that what we actually have is a horizon behind the boat slightly, because it's quite close to the photographer. It's not a black swan necessarily. Anyway, the sky is then mirage below the boat, giving you a false horizon, which is this line here. The true horizon, if you want to call it that, would be slightly behind the boat. And if you use off-center vision, you don't even have to adjust the contrast. You can see exactly where that line is.
Yeah, correct. Exactly. Next image, please. Okay, lastly, I wanted to show this as a demonstration of how we only see obstruction below our eye level. As you can see here, everything that is obstructed in this image is below our eye level. And I am yet to see obstruction taking place above our eye level. It is possible to obstruct something above our eye level, but it can only be obstructed with something that is actually above our eye level. So from what we can extrapolate from this is that the water is below our eye level, and it's closer to us than this boat actually is. Therefore, obstruction can take place. Conversely, other things can lead to this effect. For one, we know that we are in an atmosphere that does cause refraction. And we know that, just as we discussed before, light tends to bend towards the denser medium. So if we have a colder layer of air above a warmer layer of air, for example, if there's a warm layer of air on the surface of this water, and just above it is a colder layer of air, that light that is traveling is gonna bend towards the denser medium or the colder air, causing what we're looking at to sink downwards. So this could be sinking refraction as well. So there are several things that could lead to this other than just Earth curvature. But as far as the Globers are concerned, it is only Earth curvature that can result in this type of effect. All right, over.
Is that the end of your presentation?
Yep.
Very good. Excellent. So for the audience's benefit, I've just put my 3D'ized version of Muppet Vision on. I did pop it up a couple of times during your presentation. In terms of how we would actually view this, we'd get the view through this box. But as with Muppet Vision, we're seeing the actual box representative of the viewfinder in the camera. So we're seeing the side of our own head represented by this box. You wouldn't see this, you'd only see what's presented in this picture. Now, what would be presented in this picture if this mountain was a mountain and right next to you would be a gystonking enormous mountain in the foreground. These mountains here would be massive because they're right next to you. However, these mountains here are considerably further away and would be teeny tiny. But as you can see in my representation, each and every one presents itself as exactly the same size as the one next to it. So it's a very useful way of removing perspective. I don't know if Righteous Force can go back to the picture of the boat with the guy on the left-hand side, boat on the right. But when you've got a picture that's showing you something close to you in the foreground being exactly the same size as something far away, you know that there's no perspective, otherwise known as apparent sizes, being accounted for. Not that one, the cartoon boat side on Righteous. So when we do this, we can attribute a particular value to each of these mountains. We can give them a whole number value, which would be feet and inches or meters. So I can say that this is a 1,000-foot mountain, this is a 1,000-foot mountain, this is a 1,000-foot mountain, this is a 1,000-foot. And it's a couple before, it's a cartoony one that's literally just like a line pencil drawing of a guy with a boat on the right. You'll get there. So in the mathematics for Earth geometry, all of the targets remain the same exact size. And when you get your picture of a guy on the left, target on the right, well, you can write any value you like on this line. I can call this distance 10 meters, or I can call it 1,000,000 kilometers. I can increase the number on this till it fills the entire line, and it won't change the representation of the picture. It doesn't make this any smaller, because if I write 6 foot on this and 30 foot on this, i.e. 6 foot on the man on the left and 30 foot on the boat, and I put 10 million in between in terms of the distance between them, it won't change the representation. But the fact that the boat's completely vanished when you have an actual picture, I don't know if you can put anything that's actual, any photograph on, or I'll find one while you're doing it. Let's just do that. That'll do. So when you've got an actual picture, number one, you don't see the side of your own head. You can't see yourself in the picture. And number two, everything that's further away is going to get smaller. This tree here is obviously much, much bigger in the picture than the trees in the far distance because of perspective. But if you stick it side on, it's very useful for removing that aspect. And you can say that the boat, in the case of this image, that's, I don't know, let's call it a reasonable distance, 20 miles away, has slightly vanished due to angular limitations. And what I mean by angular limitations is where they draw a single line, or in the case of the Earth curve maths, they draw a tangent to their Earth curve edge obstruction physical geometric horizon. But what you've actually got is an angle. You've got an angle to the top of the boat and an angle to the bottom of the boat. Now that angle, if the boat was right in front of you, would be a much wider angle. And the further away you go, the smaller the angle becomes. That would be the apparent size of the boat. Not factored in when you put it in Muppet Vision side on. Well, that's how they've removed perspective from the Earth curve maths. They've removed apparent sizes. How do you know? Well, because they'll be giving you the sizes in feet and inches or meters, and those values do not change with distance. Unlike reality, things in reality that are further away are much smaller than things that are much, much closer to you. This tree here isn't necessarily much, much, much bigger than this tree in the distance. It's just a lot closer. Its apparent size is larger. Now, ironically, they're all babbling on at the moment because of the black swan about how the geometric horizon, necessitated in the globe model, is actually, quote unquote, apparent. Now, number one, all horizons are apparent. It's part of the definition. The apparent position where the sky meets the ground, or the position where the sky appears to meet the ground. The sky doesn't meet the ground. All horizons are apparent. But they introduce this extra horizon with the word apparent because we can't see their physical necessitated geometric horizon that's in their model, marked with an X and labelled horizon. When we can't see it, suddenly it becomes apparent. Totally redundant term. Now, the reason this is interesting for this conversation when we're detailing perspective is apparent would be the mathematics that you would require to include perspective. Apparent sizes. And they don't use them. They're not using angular size, otherwise known as apparent size, representing this boat with two lines to the top and to the bottom from your perspective. You've just got a fixed value whatever I gave it earlier, I can't remember, 30 foot boat and 6 foot man. And those values will never change. Therefore, it's easy to hijack the effects of things getting smaller into the distance till they disappear, and things will disappear from bottom up with a limited enough angle. I'll give you an analogy in a moment. And they can call that effect of things getting smaller till they disappear Earth curve. Now, as for, to round this out, this excellent presentation, perhaps, to round this out, go on.
Billy Blueballs just commented that I wonder why those fence posts are all the same size. So he clearly still doesn't get it. Yes, the fence posts are still all the same size, but because they're moving away from us, or they're further away from us, their apparent size is reducing. Now, this is the reason, they expect us to be able to see Australia from New York, because in Muppet vision, everything is the same size, everything is on the same level, and there's no atmosphere. Everything is geometrically represented as what you'd expect it to be with no atmosphere. So they clearly don't understand how this effect works. Regardless of how many times we try and explain it to them, they're just not going to get it.
Indeed. So if I give my analogy for bottom-up obstruction, because that's normally the last nail in the coffin, people say, well, things are disappearing from the bottom up, therefore they must be being physically obstructed by an Earth curve edge currently being denied and called apparent, with this redundant term included in the description of a horizon. Nevertheless, bottom-up obstruction, if I take a brick and place it right in front of me, it's very easy to see it has a very large angle. The apparent size of the brick is quite large if it's close. Now, if I push that brick, singular, out to the distance of 1 mile, there's a good chance that that brick becomes too small to see. The angle to the brick, I don't know if you can go back to the boat, Righteous, with the same cartoony, there we go. So, again, with my boat in front of me, the boat has a very wide, large angle. Whereas, in this case, if we're talking about a brick, you put the same exact thing on the horizon, the brick, once it reaches the horizon, becomes very, very small. So, in the same way as some of the leaves on this tree can't be resolved, a brick on the horizon, if this is a mile, just for analogy, would be too small to see. So a single brick at 1 mile disappears. Now, if I now pile on top of that brick another 20 million bricks in the form of a skyscraper, the angular resolution of the brick at the bottom is still too small to see. But the bricks that have been piled on it have got a wider angle. You've increased the angular resolution of the stuff on top of it. It doesn't alter the fact that at the bottom of that building, the brick that disappeared at a mile has still disappeared. The angle's still too small. It doesn't increase the angle of the bottom brick by building on top of it. Ergo, the brick at the bottom has still disappeared at a distance of a mile from bottom up due to an angular limitation. Now, if it was a boat, the boat, analogous to the brick, at a given distance will have the bottom section disappearing through angular limitation, and it will continue to disappear due to angular limitation from the bottom up. Sod all to do with Earth curve, everything to do with perspective.
Exactly. I'm glad that you added that last bit at the end, that it's the result of it's a viewing angle. Like we're not able to see that angle that's below where those bricks are, because what they could say is that if things are reducing in angular size, then they should all reduce uniformly. And they don't understand that the reason that we can't see the bottom of buildings is because of an angular limitation. It isn't just an angular size change.
Correct. So again, with the boat on screen, I can do the same analogy again. So, again, in Muppet Vision, as they like to present it, if I draw my angle to the top and to the bottom of this boat, well, the bottom section of the boat has a very small angle. And as it gets further and further away, that angle will get smaller and smaller. So if the boat was right in the foreground, the angle to the bottom section of the boat is still quite wide to the bottom section. And as the bottom section gets further away, the angle to it is more limited. It's not just one angle for the entirety of the boat. It's made up of infinite angles within whatever resolution that you can see. But the bottom, most acute angle is going to be the one that disappears the first, because it's the most limited. And why is it the most limited? Well, because we've got this line. The ground you're looking over limits your angle of view. Now, above you, you've got an infinite angle. You can see all the way up. But down here, you've got something that's going to limit the angle that you can see things at. And the further away, the more limited the bottom is going to get in terms of angular resolution, therefore disappear first. And that's precisely what we observe because of perspective.
Exactly. Not to mention that things that are also closer to us in the foreground are going to be larger in angular size than things that are further away, which could further lead to obstruction as well.
Right, last but by no means least righteous, if you can go to the very first or second slide, the one with the water levelling. The very first water level thing. So while he's bringing that up, here we go. So in this image, their assertion in Muppet Vision that we had earlier with the guy on the left and the boat on the right, we've got a straight line between target and observer for the ground and a straight line for the view, what he's seeing, dotted line from his eyes on the left to the boat on the right. Well, in this image, as you can see, and as demonstrated very well by Babs, this is raising up. These two are exactly the same amount of liquid. That's the point of the apparatus. And yet it's raising up. And that's going to continue to happen if this extended out to the horizon. You'd see all of these raising up, raising up, raising up, raising up, raising up. So not curving down away from you, like in their Muppet Vision representation, or in their bastardization of a flat Earth world, just a straight line still in Muppet Vision, where you can see forever. What's happening is it's rising up, while they tell you it's curving down. Well, what does that tell you? Well, it's not Earth curve, it's perspective. That's why it's rising up, not falling down.
Exactly. Everything that's on the ground starts to move closer and closer to your eye level the further away it goes, which is not represented in Muppet Vision.
And yet they tell you on the globe that from your position where you stand, everything's falling away from you, down. You're at the top of the sphere for everybody, and from your position looking out towards the horizon, you could draw a tangent line between you and that horizon and work out what's going to be obscured because everything's falling away from you. You're always looking down at things falling away, curving down. Drop. There is no drop.
Yeah.
Raising up. With perspective.
Isn't it funny? Isn't it funny how horizon drop is only visible with elevation? And what they fail to realize is that if you're looking at the horizon drop, you're looking at it at an angle, at a downward angle, as opposed to a straight line. So you're looking at a further distance. If you consider this to be a triangle, the base of the triangle would be shorter than the sloped side. So with elevation, you're looking through a further distance, which has more atmosphere, therefore leading to more refraction, if that makes sense. So if we're looking through more refraction, the horizon is going to be refracted more than it would be at ground level.
But their assertion when they describe horizon drop, the dip angle, is the assertion that we have a geometric horizon, a physical Earth curve. Now, as you raise in altitude, in case this isn't obvious, you should eventually get to the point where the Earth curves into a round ball that they show you with NASA pictures, quote-unquote pictures. But that's the effect. You go up higher, you see more curve, right? So they assert that that is the effect that you'll measure when you get up high and measure the horizon dip. Well, that assertion comes with the necessity for a physical, geometric Earth curve edge as a horizon. Something that's been relinquished and debunked by the Black Swan. So you can't assert that this is a physical Earth curve obstruction that you're going to measure a tangent line to, especially as they're claiming A, we've got no straight lines to draw, it's all refracted, and B, it's non-physical, according to them. So none of the geometry works in these assertions where they claim that the horizon's dropping. we all know full well the horizon's not a physical, actual place. It moves with the bloody weather. So drawing tangent lines to it and asserting that it's a physical edge to their sphere for boats to go over is beyond absurd. Now, to round this off, we as flat earthers, anybody who's watching that's new, get asked quite frequently why our boats aren't going over the edge of a disc flying up through a sky vacuum in the form of a flat earth society reification model that's literally got an edge and boats and the sea falling off it. Well, the reason we have this... I just want to get to my point. The reason this is engineered into the flat earth society narrative is because their weakest part of their argument, heliocentrists on the globe, their very weakest part is their edge. Now, they don't call it an edge. They call it Earth curve. It's going over Earth curve. That's what they say. But it's an edge to their sphere with geometry and physicality that they're all currently relinquishing because it's debunked by the Black Swan. We don't have a physical geometric horizon. And that's why they've got to ask us for our edge. Attack is the best form of defence. Rather than focusing on their edge and the boats going over it, when they say boats go over the curve of the Earth, they ask us about our edge that we don't have and don't reify. It's been foisted upon us. But it's because it's the weakest part of their argument. Sorry, go ahead, Babs.
Yeah. And things can only go over an edge. It has to be an edge in order for it to cause obstruction. And as far as the high altitude pictures that show Earth's curvature, those are cherry picked. They just cherry pick Dwayne Kellum's footage and take snapshots of when the barrel distortion makes it look convex. They don't show you when it looks concave or when it's all wonky. They only show you the cherry picked images that they want you to see that support their fantasy.
You got some questions?
Can I ask a question?
No, because Brenda's in the queue. Go ahead, Brenda.
Yeah, I have a question. Could you go back to that line drawing of the boat?
Righteous. Thank you.
Yeah, that one. Okay, now, like you said, you can draw a line. There's actually straight lines going from the person's head to the top of the boat and one going to the bottom of the boat, correct? And that angle is very wide when it's close and very narrow when it's further away, correct?
Who are you addressing the question
to? Are you talking to me?
To anybody that wants to answer, either Nathan or anybody else, right? I'm just wanted to get straight that we're on the same page, right?
I'm sorry, I didn't hear the question.
So Nathan said that with this boat, this side view, this orthographic view of the boat, right, when it's really close to the observer there, the angular size would be very large, and the further away it gets very small. Correct?
No,
yes, that is correct.
No, that's not correct. No.
But that's what you said.
No, it's not included in your Earth curve calculator. This is a representation that's distorting reality. We don't see the side of our own head. It's representative of your Earth curve maths. So when we're looking at pictures like these, we're talking about Earth curve maths, Muppet vision, not reality. That's not what happens in reality at all. But in your maths, there is no such description of the boat being close with a big angle and boat being far away with a wide angle. It's always represented in feet or meters.
But that's what you said. You said when it's close, the angle of the lines connecting, the
say
top
it a second
of the boat,
time.
the bottom
I'll
of the
say it a
boat,
second
and the
time.
person.
I'll say it a second time. It is not included in your maths. My example was to highlight the missing angular relationships in your maths. So when you say, well, when it's close, it's got a wide angle, what in your maths? No, it hasn't. That was my point. Are you going to whistle past that completely for something spurious that's not relevant to my description of your maths that does not include apparent sizes? That's what I was detailing. Do you want to address that? Because that's what I was focused on.
Well, that's what angular size means.
It's not in your calculator, though, is it? Angular size, Brenda. It's always going to be feet.
Yeah, it is calculated.
No,
Yes,
it's always in feet and meters. It's not angular sizes. You just don't understand how you calculate
what
works.
other size? It could be in inches. It could be in
no.
millimeters and meters.
Inches isn't angles. Inches doesn't change with distance. Don't tell me it's got angular size and then say it could be in inches. No, it'd need to be in an angular size.
You don't know what angular size
why are you
is,
laughing?
do you?
Excuse me. Excuse me. Don't tell me with an ad hom what I don't understand. That's an ad hominem attack. So I've got to remove you because you're going to tell me what I do and don't understand. Your maths doesn't include angular sizes, Brenda. For the globe?
Yes, it does.
No, it doesn't. You've just said it could use inches.
That's what the feet. Yes, it does.
You're just parroting. Yes, it does. No, you've just said it could use inches. Inches isn't angles.
The size is the angular size is the angle. You can determine.
Why are you telling me what you can determine? It's not in your maths. You use feet and inches, like I've said. Now you're babbling on about what you can determine. I don't care. All you've got in your maths is feet and inches for a target that will not change with distance.
And Nathan,
why are you stuttering and saying my name?
Angle theta.
You don't have angles in the Earth curve maths
to determine the length of the opposite side of the triangle, Nathan.
What's that got to do with the angular size of an object that you're?
That's how you can calculate it.
It's not in the Earth curve maths, though.
Yes, it is. Because
no, it's
if you
not.
know
You're
one
a liar.
side of the triangle and then the angle theta, then you can calculate the other side of the triangle. You mong.
Why are you insulting me and calling me a mong? You do not have angular sizes in the Earth curve mathematics. All targets will be measured in feet and inches or meters and stay those values regardless of their distance. Their angular size will not change. You drawing a sagittar is Earth curve geometry based on Muppet vision with no apparent sizes included.
The apparent size is the size that it appears, and it depends on its distance from you.
And that's not included in the Earth curve maths for about the 5th time.
Yeah, it is.
No, it isn't. Why do you keep spewing this baseless assertion? I've qualified how it isn't there. This boat in the Earth curve maths is always going to be 30 feet. And you're going to tell me how many feet are blocked based on a sagittar you will draw to a physical Earth curve horizon obstruction edge that will block it based on how many feet are missing. Feet which will not change with distance. You'll tell me how many feet and inches are missing from a 30-foot boat. Now that's not accounting for angles in any way, shape or form. You doing geometry and drawing angles from your geometry is not accounting for angular size. You are incorrect or a liar. The Earth curve calculator does not include apparent sizes.
Nathan, is there anything...
Shut up. Don't ask me a question. You're an idiot. With that, I'll say a huge, massive, enormous thank you to all of you who did tune in on the Nathan Oakley 1980 live stream for hopefully smashing the super chat, liking, commenting, sharing, subscribing. Oh, goddamn camera. Let's go to the backup camera. Liking, commenting, sharing, subscribing, and all that good stuff. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. Stay tuned once again if you're watching on Nathan Oakley Premiering Stream. I'll see you all in the next video.
Oh, what a day! What a lovely day!
Yeah, they've hijacked perspective, basically. They've taken the effects of things getting smaller and smaller into the distance, kept the values for those items the same at any distance, and called the effect Earth curve, using angles of geometry and drawing sagittars, not accounting for things getting smaller into the distance. People who come here and say that it does account for angular size are just liars. Or stupid. Don't care which. Good presentation, by the way, Babs. Well done.
Thanks.
Should have left you alone, because clearly when you were using certain terms, you were building up to using the correct terms, and I just sort of jumped the gun, assuming that you got them wrong, but you hadn't. You were just using common vernacular to build up to angular descriptions later on in the presentation, so I'm sorry for interrupting. I should have just held my tongue.
Oh, no worries. It is easy to get these terms conflated or mixed up, so it's good that you ask those questions for clarity.
Can
yeah,
I
one or
pose
two
that
times.
question?
Yeah, sorry, I completely forgot you, 10th man. I'm really sorry.
That's all right. That was interesting, the back and forth. Blue Marble Science, Babs said he put a text, so I went and looked at the text, took a screenshot of it. I'm going to read it. I just need clarity here because I don't get it. Blue Marble Science. In the orthographic view, the observer and the object are the same distance away. Therefore, no change in the parent size due to perspective. Quote me accurately, or I may do another video.
Read him again.
Okay. In the orthographic view, the observer and the object are the same distance away. Therefore, no change in the parent size due to perspective. Quote me accurately, or I may do another video.
If things
So my question,
remain in orthographic view, they're not necessarily accounting for perspective at all. That's the first issue. That's the point of using it. You're normally drawing a single line between target and observer. This is the line that Brenda took. Let's discuss your understanding and knowledge of orthographic representations, rather than addressing the point. The point being that why is he now asking us about the angular representation in an orthographic view when his mathematics using orthographic view doesn't use angles? So, Blue Marble Science, you complete numpty. Why would you be asking us about the angular representations that aren't included in your orthographic maths? Is our acumen about random orthographic maths that do include angular sizes relevant when your maths doesn't? Now, given that you're asking us about how angular sizes are represented in orthographic view, I'd like you to show me those angular sizes in your mathematics. Now, bearing in mind I've just made it quite clear that they're not there, I'll just win this out straight away and say, you complete loser. You, like Brenda, have missed the point and tried to highlight a straw man to burn in terms of our acumen and understanding about orthographic representations that do include angular sizes when yours don't include angular sizes, the point of our argument. So, we'll discuss the angular sizes and how they're represented in orthographic view as soon as you show them in the maths for an earth curve that hijacks perspective and doesn't account for angular size change. So we'll discuss them when you show us them in your earth curve maths, Blue Marble retard. They're not there, moron. That's the point of our argument, not our acumen in terms of how well we understand orthographic views, not necessarily applicable to your earth curve maths that doesn't have angular sizes in them, you complete dick. Hope that addresses your question. Quote me precisely, or I'll make a video about it. No, I don't give a shit. You're a moron.
all right. I posted it in Ballbusters if you want to see it. But my question is, well done there, by the way. My question is what he says after he says orthographic view. I'm not getting his synapses here. The observer and the object are the same distance away. I don't understand what he's trying. The observer and the object are the same distance away.
Yeah, I understand what he's doing. What he's doing, he's saying, Righteous, can you bring up the boat again? You there?
Yep, hold on.
Thank you. He's saying the man on the left and the boat aren't moving. They're the same distance. They're a fixed distance. So there will be no angular size change. Well, yeah, that's because this cartoon's not moving. The boat's not actually sailing away from him in the image. So no, this is never going to represent an angular size change. But it would and could, if I just simply draw a line that represents an angle to the top and bottom of it, represent an angular size. But his maths doesn't include angular sizes. So he's justifying it by saying, well, when we've got a fixed picture, there's no angular size change. So there's no delta of the thing we're asking to be included in the maths when the maths has hijacked the very effect of angular sizes. Oh no, let's detail angular sizes and how they change. And in this picture, they don't. So his point is, in this picture, there's no representation of an angular size change. Well, no, that's because there's not a second boat in the picture and two lots of angles being drawn to it. So no, based on your language, no, you don't need to argue very much about an angular size change in this picture with a static boat. However, your mathematics for a globe doesn't include angular sizes. That would be the point we're making. Maybe make a video about how your maths doesn't include angular sizes and the boat's always going to be 30 foot. Even if I draw 1,000,000 miles on this line, our point being, this boat will always be 30 foot in your maths. It'll never change in size, even though it's getting so small, at 1,000,000 miles, there's no sodding way you'll see it. But your maths will still see it. You just draw it halfway around an Earth curve. I don't know, 3,000 miles away, but it's still 30 feet. Yeah, well, it hasn't reduced in size. Angular size, apparent size. For your apparent maths that you don't have. Fools! Blue Marble's completely retarded. He thinks his clever use of wording's going to catch us out. No, I don't think so, Blue Marble.
He's just conceding. He's just conceding our point essentially by saying that side-on views can't show perspective. That's our point, and he's conceding it. And the people that watch him are too stupid to realize that. So we have to educate them on it.
That's exactly right, Babs. That's my point. The way he forms this question is exactly what Babs says. He's conceding that. Now, has he ever stood at a dock and waved goodbye to people leaving on the cruise ship? Does that cruise ship not get smaller as it gets away from you in distance? Is he going to say it's the same size as it was in front of him in the dock where he couldn't see anything because it was blocking things that were behind it? Is this guy insane?
Yeah, I mean, according to him, on a flat Earth, everything is the same size with distance. Nothing changes. You should be able to see Australia from New York.
Yeah, they're crazy. Him and Brenda both are crazy, man.
Yeah, they're so brainwashed by their own mathematics that excludes perspective that they expect us to see forever on a flat plane because their maths implies that you can see forever if you straighten out the line that's obscuring it. Now, what that actually tells you is they've hijacked the effect of perspective and called it Earth curve. So if you straighten out the line in their representation, this would be a quarter of a sphere with the boat down here somewhere and the man up here somewhere and a sagittor and a tangent and all sorts of geometry and angles being drawn, but no angular sizes. The boat on the other side of the curved Earth would be 30 feet and the man rising up and down and giving you an apparent horizon, geometric though it is in their model, would be 6 feet. And that's all the maths ever shows. So even though in their geometric maths on the Metabunk site, for instance, it's literally got a quarter of a sphere in the pictorial representation, that quarter of a sphere, what would that be representing? Several thousand miles. Well, you can't see a boat that's 30 feet at several thousand miles, but in their maths and their depictions, you can. So when you straighten out that curved line that's got several thousand miles represented, and you drawing a straight line between target and observer, and just saying that the reason you can't see it is because of a bloody Earth curve getting in the way, that's no longer geometric and capable of obstruction unless you suck all the atmosphere out. But that aside, when you straighten out the line, they think that you should still see the boat because there isn't an Earth curve in the way. It's like, well, no, the Earth curve was never in the way, but the boat was definitely too small to see halfway round or quarter of the way around your sphere. If it was a sphere, you'd still have the effects of perspective, but they're completely ignored in your maths. In reality, hijacked by their maths and called Earth curve. Things get too small to see as they get further away, it's perspective. Well, in their maths, that doesn't even happen. Things are falling away from you even though they're rising. If you stand with a boat right next to you on the harbour, you could very easily be looking down at the bottom of the boat. Well, by the time it gets out to the horizon, it's no longer looking down at a very low angle to the bottom of the boat in the water beneath your feet. It's rised up as it's gone away from you with perspective. Isn't that amazing? Just like those depictions of the water. Well, the bottom of it is rising up like the boat would do if as it went away from you. Yeah, you'd look at the bottom of it, you'd have to look right down at your feet to see the bottom of the boat when it's in the harbour. But as it goes out towards the altitude, goes out towards the horizon, is it going to be curving away, down, falling, dropping, with the perspective view that they remove and hijack with Muppet vision? No. The bottom of the boat's going to rise up and up and up and up and up and up and up until it reaches the horizon, and then at the point of the horizon's where it's too small, and it'll start disappearing with angular resolution limits based on the deck that you're looking over and the limited angle to the bottom of it. None of which is represented in this view. All you've got in this view is an eternal view forever and a value that you can attribute for the distance between it, and never will it get too small to see. Precisely why they've used it for the Earth curve maths.
Yeah, according to the Globers, on a flat Earth, there is no atmosphere and there is no perspective. You only have atmosphere on the globe. That's why you only have atmospheric effects on the globe. And that math doesn't apply to flat Earth, which is ridiculous. I mean, wouldn't the same things apply?
Well, not only would they apply when they qualify them, so when Andrew Thomas Young does his detailed explanations for how refraction works, he disclaims at the very end that they're all done on a plane. None of them are done on a curved surface. And then he just gives you the mathematics for assuming R if you want to do it on a curved surface with the maths at terrestrial refraction rates. So he does a little magic trick where he baits you in with refraction effects all detailed on a flat surface and then says, oh yeah, these apply to a curved Earth. We just changed the maths. Go to this other website and he'll tell you all about it.
Exactly.
Had somebody release, I can't remember who it was to give him credit, but somebody snipped out a piece of Fight the Flat Earth saying, basically, something that gets completely debunked by that statement. He's saying that you would, exactly that, I think you wouldn't have any of these refractive effects on a flat plane. They're all mandated by spherical surfaces. And I can't remember to give him credit, but I left a comment underneath saying, hang on a second, all of their actual references from their global worshipped Andrew Thomas Young, they're all done on plane surfaces. Literally none of them are done on curved surfaces. His argument being, oh, these are all necessitated by a curved surface, but yet none of the examples given by Andrew Thomas Young are using curved surfaces at all. Just a disclaimer for how it is all actually curved, even though they're all done on plane surfaces. So all the examples, not one back his argument that they're all done on curved surfaces. Then none of them are. What a complete idiot. You think he'd actually look before spouting that nonsense?
So then,
right now, is Fight the Flat Earth on Sean Hawkins' level or on Brenda's level? I've heard him say some pretty stupid things.
Hold on, I didn't hear either of you, 10th Man or Babs, one or the other. Babs.
Yeah, what I was saying was, is Fight the Flat Earth on Brenda level or on Sean Hawkins' level?
I don't have any interactions.
I've heard him say some pretty stupid things in the past, so it's kind of hard to...
Don't know him. Don't have any interaction with him. Don't care. But I do see occasional things getting trimmed out from him that are quite useful. Him asserting we have physical geometric Earth curve obstructions. I've trimmed that out because Helen Degenerates trimmed it out, and I was like, yeah, that's useful because they're all denying it at the moment. And this is another example where someone's trimmed out him saying, all of these atmospheric effects must be happening on a curved surface. It's the only way they can. Or words to that effect. I'm not doing a terrible job of paraphrasing, but either way, you're like, wow. Literally, your examples on the website that you're referencing at the moment are all disclaimed to have taken place on a flat surface. Oh my God.
Yeah,
well, that was
ridiculous.
that was going to be my comment. That obviously, when he did his calculations on the refraction page on his website, he said they were done on plane surface, right? And then, but if you want to reify it to globe, go to these other websites. Well, wouldn't that mean that he did those calculations with no atmosphere?
No.
Yeah, because on their own rhetoric is the only way you can get the geometric measurement proper is if you had Earth without an atmosphere.
No, they won't have done that. I know they have a sky vacuum that's defying the second law of thermodynamics, but there's never going to be a circumstance permitting them to do that now, is there? So no.
I know I'm being funny about it, meaning they're saying that the only way is if Earth didn't have an atmosphere. But when he says he got his calculations, he did it on a plane surface. Well, with atmosphere or without? Make up your mind.
Yeah, that's a good point.
There's only one level too. It's the Brenda level. There's different shades of it. Fight the Flat Earth is definitely below that. Hillbilly Blue Balls, the redneck retard, is like echelons below Brenda. Mrs. Frigging Inches is angular size, and then call somebody an idiot. Right?
Really?
That's like
I thought Sean Hawkins was the lowest you could get.
Obama, a genocidal maniac.
I think Babs is trying to establish what the bottom of the pile is. Is bottom of the pile Sean Hawkins?
No, Brenda.
Yeah, I would argue that Sean Hawkins is the bottom of the
you
pile.
have no argument.
Can go
Brenda. There's only one level, it's Brenda, and there's different shades just above or way below.
Is Sean Hawkins just below? That's what's being asked. Don't know why it's important, but that's what's being asked.
Sean Hawkins.
Who?
I mean, as hard as this, I have heard Brenda make logical arguments before, but I've never heard Sean Hawkins make logical arguments. Ever.
Post one. Yeah, I want to see one.
You mean? I think let's correct him. I think he means he's heard Brenda claim and attempt to form logical arguments.
Right. Yeah. To be more precise.
Yeah, well, many people can claim many different things, right?
Right. But Sean Hawkins doesn't even know what he's talking about half of the time.
And Brenda does?
Good point.
Hey, why do you guys even entertain Brenda anymore? She's clearly intellectual.
I don't even know why we entertain the rest of them. You got Hillbilly Blue Balls, the redneck retard, showing up on a friggin' video. Please make more videos. Showing up trying to disprove gas pressure without a container by showing up with pressurized gas in a container. This is tantamount to disproving the existence of dogs by broadcasting live from Blue Tick Coonhound Kennel. So, Hillbilly Blue Balls, the redneck retard. There's no hope for you. You're such a dumbass. Please continue to make tons of videos. Thanks.
Sounds like the other day where Zanuck tried to say that level means curved. And then everybody laughed.
That would be akin to saying
that's that level is perpendicular to gravity nonsense.
Yeah, we had that the other day, didn't we? Same Brenda again. Why do we have Brenda? It's an open door policy, that's why. Anybody can come.
Black Swan.
But we have to endure.
Can I say something to back up Babs? Can you hear me?
Go ahead, Paul.
Yeah, go ahead, Paul.
I just dropped a screenshot of the refraction simulator from the Walter Midland, whatever his name is, and I was able to drop things beyond the horizon using only temperature. It's using their own simulator, so refract on a flat surface, on a flat Earth. So just saying, if you guys want to share that or see that.
I can't share it with the panel, but I've got it up on screen for the audience.
So yeah, if they disclose any kind of refraction with even in a flat Earth, it's still, I'd use it on the simulator and replicated it.
Yeah, I can't see it. I'll have to watch it on the after show.
I DM'd you in the Discord, so look under your DMs. I sent it to you directly.
Oh yeah, I see it now.
And last week, I actually did it on screen. I actually just changed the temperature 5 degrees at the water level and was able to rise and lower it just with 5 degrees temperature variation.
It's in Discord live stream.
Right. That's the sinking refraction effect where the light is bending upwards towards a colder air.
Right. Yeah. The water temperature is warmer at water level than it is at higher up. Yeah.
Exactly. Yeah.
Well, Andrew Thomas Young has a whole page on refraction, and at the bottom he says we do this on what? A plane. For goodness sakes.
Yep. And in order to talk about refraction in a curved atmosphere, we have to take some geometric considerations. Isn't that nice? Which will be held on a separate page.
Clown.
Yep.
Checkmate.
Black Swan.
Where the fuck is my geometric horizon?
Yeah. I can sell any horizon you like. Smash the super chat if you're watching another programming stream. But just not a geometric one. They're like hen's teeth or rocking horse droppings.
Hen's teeth.
Actually, can I put an input here? I mean, not many people will watch Fight the Flat Earth. I do it out of I don't know, strange thing. But he did a debate at the weekend with Hip Hop Hippie, and in that debate, he was using some military technology that they'd used to explain, I think, why the geometric horizon wasn't seen. I think, and I managed to get out of it that the military have used the geometric horizon technology of it not actually appearing to be there. So but get ready for this, because the geometric horizon has been militarized as a cloaking technology by Fight the Flat Earth. I need to look into it to make exactly what he was trying to say within the debate. But yeah, he was trying to say that they can't see things that are there. And I think he was trying to link that to the geometric horizon, possibly.
But if it's technology, that's fine. He would have just cited his source, right?
Yeah, it was like a sheet of film or something that the military using to make
I don't mean describe it. No, that's not what I mean.
He trying to say that the military has a way to uncloak the geometric horizon?
No, I think the military have found out the properties of the geometric horizon as being, it's not that, it's like an invisible thing, and they're militarizing it. Weaponizing the ability of the geometric horizon to be not there. It's seriously, it's going to take looking into. Yeah, just watch the debate with Fight the Flat Earth and see what he does with this technology. I mean, I couldn't understand what he was trying to get at or why he was trying to bring it in. It's I don't know, revolutionary if you watch it.
I think you got a point, because Rumpus had to go to the bottom of the barrel and say it was the Matrix. Now, Fight the Flat Earth is going to the bottom of his barrel and saying, wow, we've made it disappear, and we're going to take that same technology and apply it to military armament.
Yeah. Yeah, it sounds fantastic. I'm sorry. It was a huge leap when I watched it, but I was sat in awe for about 15 minutes when he was going through it, trying to work out what he was trying to say.
Was the argument... Go on, Owen.
So he was trying to basically make it up on the spot.
No, he's worked out a whole piece. There was bits, he had videos and everything. It was a piece that he's presented.
Based off Star Trek?
Oh no, fair enough.
I don't know.
A piece as in like an art piece?
No, he had a fella walking behind a thing and disappearing, and he had like a little miniature model of a jet that wasn't there. And then when you lifted the camera up above this plastic film, it then appeared.
Okay, but can you?
I think
hold on. This has piqued my interest. What I want to know is how this relates to the geometric, quote unquote, apparent horizon paradox that they currently have.
Exactly. That's exactly why I was gobsmacked at how or what he was trying to do. Like, I honestly, you'll have to watch it in order to try and, because like you were at the point now where you have to jump out of your own head, because these people that we're trying to imagine what they're thinking, like you can't even imagine what they're thinking.
I really appreciate that you've done that, and I'm very grateful because you can sort of praise what he's explaining in a vague way, which is what your point is, right? But I'm saying, no, I just want a concise explanation. What is your debunking? So over the last 3 months, I've done daily searches for people's rebuttals against the Black Swan. And when I come across them, if they're decent enough size, so a guy recently that Anthony had addressed before, I'd not come across him until now, was AB Science. Now, he did a fairly concise rebuttal to the Black Swan. And that I can get my teeth into. But if it's wishy-washy, vague explanations about how things happen with a video about something happening, it's like, just give me the broad strokes. What is your argument? So with AB Science, yeah, the wishy-washy boring bit is when he goes through the mathematics of how light can refract. Right, so light's refracting, so the light's bent. Okay, fine. But I can get to that. I can sit through 10, 15 minutes of a video to get to through their boring waffle to get to their point. In his case, AB Science, the horizon's refracted. So not geometric then. Well, that was a wonderful video to respond to. Great. A couple of thousand views later and lots and lots and lots and lots of comments. Share your pain fundies. With them basically saying the same thing. The horizon can be refracted. And I rub my hands together and go, oh yeah. So not geometric then. It's great. I like these idiots walking into flamethrowers. But I want to know what flamethrower they're actually walking into, so I can burn them with it.
Doesn't it just basically come down to they're trying to rebrand the whole a thought experiment of just imagine it to be a curve, and they're using
no. That's supposed to be hidden in the depths of the small print, Arwin. So yeah, you find that. We found that. We're exposing it like it's common knowledge, but it's in the depths of the small print on an Andrew Thomas Young website. That's where that information resides. Taking geometric consideration when looking at a not actual position we call the horizon, the geometric consideration is all they want you to do. They don't want you to know that it's a thought experiment, that it's not actual, and you're just taking geometric consideration. No, that's the last thing they want. They don't want that bit of small print getting out. That's our job.
Well, they might want to drop it, but it would be like somewhere halfway a 20-minute presentation that's really just about one thing.
Exactly.
And you just slip it in.
Exactly. It needs to be weaseled into a 45-minute presentation by the rumpus. Disclaimed very early on, brushed over and ignored for the rest of the presentation. That's what it needs to be. Not dwelled upon and highlighted and pointed out and read out over and over again like we're doing. Yeah, the horizon's not actual. Now, your model says it's physical and geometric, but that's only when you take a non-physical, non-actual place and then make some geometric considerations. In other words, think about it as though it is physical. It's as simple as that. And they tell you it's just in the small print. The print we're shouting about.
So, Arwin, they went from pseudo-Romanian force space to pseudo-Romulan cloaking horizon.
No. Sorry.
I don't think so.
It's too far.
Too far.
Well, it can't be a cloak's chance, man, because a cloak makes it disappear altogether. It has to be a hologram. So it has to be, that's what it is.
I don't know. I just see it as a very elaborate reconsideration of the Earth being a sphere and the horizon being geometric. Just
listen, they already fucked themselves.
Your story some more and reconsider, please.
They already fucked themselves with we've never seen the geometric horizon. So my man is going to try to find a way to uncloak it. It's as simple as that. and say, "Oh, look, the military uses the geometric horizon. They can see it because they have technology." Yeah, that's it. Shut up, man. It's fucking stupid. These guys are so lost that it's just not even funny.
There's so much pain. They can't handle the cognitive dissonance.
That's all right. That's why we're here, for them to share their pain as we laugh and dance into the sunset.
It's PTBSD, post-traumatic black swan disorder.
Yep.
You should have heard it on Discord. I think it was either Friday or Saturday. I can't remember when it was, but they were trying to debunk the Sea Sparrow thing, saying because the max range of the missile was like 35 miles, and that's only why it was going that. And of course, they was arguing air to air or ground to surface to air instead of surface to surface, and they were squirming really hard over that one. That was pretty funny. I said has nothing to do with the missile. It's all about the line of sight of the radar, dude. Come on now.
Yeah.
I see Rumpus in the chat. Can I ask him those 5 questions? Rumpus, if you come on, I'll ask you the 5 questions. I just want you to come back with an answer at a future date.
What chat?
Well, he was in chat earlier.
The live chat. That's long over.
Yeah. No, I know that, but I'm just wondering if he's still
Yeah,
listening.
that was over yesterday, man.
Yesterday?
Or like half a day ago.
No, it's not here, sorry.
Oh, okay. We'll wait tomorrow, maybe.
I got a question about equivocation fallacy. You know how they use looming for 2 effects, looming and Fata Morgana? Can that qualify as equivocation fallacy, even though they don't know they're using it?
If you're
that makes sense what I say?
If you're using 2 descriptions for one thing, then yeah, that's an equivocation, but that's not necessarily how they equivocate. The equivocation they use is any actual effects that are taking place in the air we're looking through versus geometric terrestrial refraction at 7/6 of the radius value. That's where they equivocate.
Now it's taking one issue or one term in 2 or more different senses. It's the reverse of that.
Say that again. It's the total opposite of what I've just said. I'm a complete idiot. Say that again, Anthony. Say that again, Quantum Eraser.
Anthony's correct. Yeah. It is, instead of 2 things into one, you're taking a term and using it in 2 or more different senses within the same argument. That's equivocation.
Can I give an example potentially? I think you brought up in the show earlier. When they say vacuum, they mean differential pressure. But when we say vacuum, we mean actually less stuff there or no stuff there. Would that be an equivocation?
No, an easier one would be gravity. When they talk about Newtonian gravity and then slip in, yeah, it's the bending of space and time. That's equivocating.
What, we're talking tables now?
No, don't.
So, has anyone figured out how much time there is in a table yet?
Yes.
Curious.
Yes. Depends on when it was produced.
It depends when it was delivered by Home Depot. You can qualify it.
Well,
it depends how much time it's spent in Brenda's presence.
Tables, when you buy them new, it's like 3 years.
No, it depends on how.
But how can they get away with saying shit like that? I do not understand. Like, does she not hear herself?
You're going to need a timetable for that.
It's different. It's different based on who's measuring it. Like if you measure it and it takes you a certain amount of time, as opposed to Granny Wilkins, then it would have 2 different space-time continuing measurements.
But hold on, you can't technically
so therefore the gravity would be different for each one of us then, is what you're saying, since it affects time differently, no?
It's your own personal space-time.
Oh, shit. So my table has different gravity depending on who's near it?
Yeah, if you bring Granny Wilkins in and she measures it, she has a different space-time continuum.
Hold on, space-time...
Fuck, I don't even know why I go to school. This is amazing.
You're getting it all jumbled up. Space-time is not gravity, it's just the cause of gravity.
Well, how about if you buy a table from IKEA and you put it together in 45 minutes and have 10 screws left over. What's that?
Well, you have to take in the time conversion from Sweden, don't you?
Then you haven't taken enough time.
Then you're screwed.
No, this is just spare screws.
But isn't down the direction in which time moves more slowly? So if you measure the table at the ground level, don't you have less time than if you were to measure it at the top of a roof?
This is all hurting my head.
Yeah, it depends what time of day you do it at, too, though.
Hold on.
Hang on. Chocolate's argument has legs to stand on. Go on, Chocolate.
Yes.
Well, actually, they have to say time is moving slower at the bottom of the table and moving faster at the top of the table. That's what they have to say. Because it's closer to the center of gravity.
Yeah, but doesn't time move more slowly at ground level?
Hold on. Equivocation fallacy. The time is not the cause of the gravity.
That may explain the bubble gum I found under my table when I went to school from 5 years before, still being there.
Then you measure its angular size in inches.
Let me chew on that for a while.
Do that. But
So equivocation is where you have like a double entendre, but you're using it with only one description of something. So in other words, if it was a joke to say gravity in one context being mass attracting mass and then the other being bending of space-time, if there was a joke that used the double meaning of those same word, different meaning, but you're actually using it in the same context, so it's a double meaning thing, correct?
A joke.
Double entendre.
what? No, but mass just doesn't attract mass. That's just an absolute
Forget gravity. I'm talking about equivocation. I'm just trying to wrap my head around equivocation.
So would that be mass and mole then? Would that be equivalent? Same definition to...
No, it's the opposite of that. It's one term, like gravity. Let's say somebody starts talking about gravity, right? And they go into a long spiel, and it's not Newton, but Reverend John Michel, C.V. Boy's gravity. Let's keep it simple. Let's just keep it Newtonian gravity. So they're talking about Newtonian gravity, and all of a sudden, like, they slip in, well, no, that's space-time geometry. Right? Well, that's two different definitions for a single term, gravity. That's an equivocation.
Isn't that also a double entendre?
Hold
on. Also called a bait. It's also called a bait and switch.
Yeah, so I was right the first time then. So when I was describing them talking about atmospheric refraction, as they term it, and you've got, you know, looming, sinking, stretching, stooping, mirages, versus bait and switch, which is what they slip in when they equivocate, which is to say terrestrial refraction. So they're talking about refraction, talking about how things really work in the atmosphere, and then next thing you know, you're talking about Sidon geometry refraction at 7/6R. That's an equivocation, is it not?
Yeah, it's a jumbled friggin' mess because they put looming in with terrestrial refraction, right?
Oh, they've scrambled the eggs a bit more.
They have.
Well, that's fair enough. They did the same with Coriolis. It's to be expected. Doesn't change the argument.
No, because looming.
Also,
remember the definition. Remember the definition of looming that he gave, right?
Not really. I don't focus on this side of the argument, and I've always. This is going to sound like I'm saying I told you so, and I'm not, because it's absolutely valid to make it pegged to the wall of what type of refraction is being used when they say refraction. Because my argument also hinges on that as well, when I'm like, well, we only have one horizon. You can't have two, one that's geometric and one that's refracted. Well, to know what's refraction when detailing it, so you're not equivocating between one or two different things, is then slightly more convoluted if you interlace terrestrial geometric 7/6R refraction, also called standard refraction, with looming, an actual effect that you could observe. It's just detailed wrong. The actual description they give for looming is wrong. So we had this earlier on. Babs gave a presentation, I don't know if you saw it, and he's trying to explain how they describe the boat being lifted up through atmospheric effects of light bending, when in reality you've got a mirage of the sky below, and the boat's in exactly the same place it would be on any other day. but they're describing looming wrong and then interlacing it with 7/6R. It's like, yeah, scramble those eggs just because it's going to be confusing to your average Joe, which kind of annoys me, but we're used to it, right?
Well, that's the only it's the only direction this argument's going to go, though. No one's going to admit to ours. So what is there to be expected at this point?
They could scramble that argument with us, but when they come here, it's over easy.
As far as I can tell, boom boom. As far as I can tell, they've just nailed their hopes to the redundancy of the word apparent. It seems to be the consistent theme. 2 horizons, 1 is apparent.
So, yeah, what I find funny is you guys ask for evidence of Brenda, for example, who has 4 horizons, but they never ask us for the example for us, like, because they know it's right in front of us. So.
Yeah, the standards are very high in one direction.
Yeah, it's all the trend nowadays for the ballers to basically complain to us and tell us that we have to prove their model to them. That's like the ultimate baller tactic now.
Yeah.
Oh,
Why do we need a geometric horizon?
How many billions of dollars spent on the other side?
Yeah, that's the most common one. I correct Darwin. They'd be like, why would we require a geometric horizon? It's like, your religion is that we have a geometric horizon. Why are you challenging me to prove why your religion, which you've asserted, should stand as true? I'd just rather welcome you to Flat Earth when you ask me a question like that. Why should we have a geometric horizon? Because it's your religion. Good job you realise you don't have one. Welcome to Flat Earth.
Why would we have a geometric horizon, aka curve, which boats used to go over back in the day and get obstructed? And we would argue with you guys that these boats are being obstructed by something physical. Why would we have that? Oh, Black Swan showed us that we don't have a geometric horizon, in which now you guys got to say we've never seen it. What are we calculating in the calculator for? What are we using that for? What is that number? If we've never seen it.
I think that number is just a geometrical consideration.
There's a consideration. That's nice. Thank you, Andrew Thomas Young. Now we understand.
We've never had one. It's a Jedi mind trick.
I'd like to address the supposed boycott.
The what?
But anybody what it is like back when I was a kid, I got whooped pretty good by this kid at school, and instead of just admitting to it, I would say that I would just stay away from him and tell everybody that I won the fight. In my head, I had to do that for my pride.
Right? And just goes to show that there is pride involved with this religion. A lot of people that get into it, that really get into it and that master the religion and all the tricks and all that and play the game, they pride themselves for knowing it. So they have personal pride invested. And then when it's proven to them, when their cognitive dissonance is endangered, and it's being revealed that it's all complete bullshit and that it's more obvious than they would like, that's when their pride get hurt.
So if they're so proud, why don't they just stay in an arena where that pride is not challenged? Why don't they just go to Star Wars conventions and play with lightsabers? Why are they here if they're so proud of their model?
They do.
Because it is being challenged, because even the commoners that before were basically too scared or like too uncertain to even address the entire issue, they would just leave the ballers to their spin doctor stories. Well, the commoners, it's just everybody's heard of Flat Earth now. So they don't have this safe space for their ego and their pride anymore as much as they used to in the general society. Because people are now looking at them like, hey, he's like a glober. He's like one that really believes in the globe for some.
So you mean to say like the normies are turning to these guys who have crowned themselves as defenders of the globe for hope?
They want their safe
Is
space
that what
back.
you're
They want
saying?
adoration back. They want to be considered the really smart ones again. That's what they want.
Yeah, unfortunately, they turn to the wrong people.
That's not gonna work.
Well, I can say that my pride was the biggest thing that kept me from accepting reality when I first come to this subject. My pride got in the way a lot.
Yeah, can imagine.
My pride won't allow me
nobody
to
likes to
accept
believe they've been
bullshit.
deceived for years.
As much as I might be used to the bullshit, my pride and my honor will not allow me to accept bullshit given to me by another man. Sorry. So they can keep that story until it's proven to me that I live on a magical spinning water ball in a vacuum.
So I just want to find out, is my mic working now?
No, what I'm saying is when I
Sorry.
was so young when I accepted it, that when I got older, my pride would not allow me to look at it again with a critical eye.
I get that, but I think because with me, I never stopped questioning it. It always bothered me, like just like an itch in the back of my head. Like, what the hell? This is not right. And I refuse to stop questioning it, no matter how crazy I sounded to people. But yeah, you're right. At some point, I was just like, I guess this is just the way the world is, and apparently somebody knows better than me. Until you realize that they don't.
Yeah, I was on the fence all the way up until the Black Swan, and that just sent me for a loop.
We only heard the end of that. You were very quiet at the start.
Sorry about that, man. I had somebody at the door. You were talking about equivocation again?
No.
Hello?
We're done with that.
Did we solve the equivocation issue?
I think we
No,
solved
you
that.
just got a compliment about your black swan, though.
Really? By who? President?
You said the president.
I was saying that I was on the fence all the way up until the Black Swan argument.
Good to hear. And with that, I'm going to say a huge, massive, enormous thank you to all of you who did tune in on the Nathan Oakley primary stream, for hopefully smashing the super chat, liking, commenting, sharing, subscribing, and all that good stuff. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. Another massive thank you to today's Discord and G+ panels for making this after show possible. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!